Today we're going to be drawing Lewis dot diagrams. So we're going to draw out fluorine. So fluorine is F2, so I should have two Fs. Then I'm going to be drawing my valence electrons around it. Fluorine has 7, so I'm going to draw 7 valence electrons. So now only the single dots, y'all, can make bonds. So I'm just going to connect the dot. So I know there's a bond between one bond between these two F's. So now to finish out my problem, I'm going to be redrawing it to make it look nice. And this is my final answer. You guys can count the total number of electrons and number of electron pairs afterwards, but you really don't need to using the shortcut method. So nitrogen, N2. So I know there are two N's. Nitrogen has 5 valence electrons. We have the single dots connecting. And I'm going to circle those connections to tell me how many bonds there are between. And I see that there are 3. And notice that there are lone pairs on the nitrogen as well. So that's what I'm going to draw. Nitrogen with a lone pair and 3 bonds between. So this is H2S. I know that we usually tell y'all that the first element goes in first, but let's take a look at that. This is hydrogen. Hydrogen only has one electron, valence electron, so it can only make one bond. So it cannot connect to another hydrogen or to a sulfur. So we're going to put sulfur first in the middle. So sulfur, and then the H will go on either side of it. Now drawing our valence electrons, we have sulfur having 6, hydrogen having 1, connect the dots. So I know there's one bond between this hydrogen and sulfur, and this hydrogen and sulfur. So I'm going to draw that out. S bond with H. And I'm going to draw my lone pairs on either side. And that's my structure. Whenever I see carbon, I have to put carbon in the middle. So carbon goes in the middle. I'm going to just put it in that order, same order. Put in the valence electrons. 1, 1, 2, 3, 4. 1, 2, 3, 4, and 5. So the single hydrogen, single carbon, and note 1, 2, 3 bonds, and 1 bond here. So I redraw it. And then the lone pair. Okay, that's it. So here I have one last example. Sulfur and phosphorus may have an extended octet. They may hold more than 8 valence electrons. So this is clearly identified when we have more than 4 bonded around sulfur or phosphorus. So when this occurs, y'all, we need to calculate the total number of electrons and draw it using the traditional method. So I'm going to go through the traditional method with y'all. So sulfur has 6 valence electrons, plus fluorine has 7, but there are 6 of them. So the total number of valence electrons would be 48. I divide that by 2, and I get 24 pairs. So pairs are the bonds and lone pairs, okay? So now I draw sulfur in the middle. And I have 6 fluorine. So I need 24 pairs. So I'm going to start adding my pairs now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 pairs. Everybody is considered to be stable. So this is my structure, y'all. If you guys have any more questions, ask your teacher. Have a good one.